Again, welcome back to Inferential Statistics in Decision Making. This lecture covers the normal approximations to binomial distributions. Our main objective is to determine when the normal distribution can approximate the binomial distribution. Also, how to find the correlation for continuity. Also, how to use the normal distribution to approximate binomial probabilities. So the normal distribution is used to approximate the binomial distribution when it will be impractical. Again, the key word here is when it will be impractical to use the binomial distribution to find a probability. So again, a normal distribution is used again to approximate the binomial distribution when it's impractical to use the binomial distribution to find a probability. Now, a normal approximation to binomial distribution have this condition here. The condition is if NP, again, N is the sample size, P is the probability of success, and Q is the probability of failure. So always Q equal to 1 minus P. Now, if NP is greater than or equal to 5, and also the NQ is greater than or equal to 5, then the binomial random variable X can be approximately normally distributed with the mean equal to NP. And also the standard deviation will be the square root of NPQ. Again, N is the sample size, P is the probability of success, Q is the probability of failure. So Q equal to 1 minus P if P is given. Now, from this graph here, we can see that as the sample size increase, our histogram will be converting to or changing to normal distribution. So when N is 4, we have a perfect histogram. When N equal to 10, the size increase, we can see the histogram is transforming to a normal curve. Then when N is 25, we almost have the normal curve. And when it's 50, now it's normal. So here we say that as N increases, we can see that the histogram approaches again a normal curve. Now we have one example here. We should decide whether you can use the normal distribution to approximate X. Again, X is our random variable. If the number of people who reply yes. Now, if you can, we should find the mean and also the standard deviation. So here we have 51% of adults in the US whose New Year's resolution was to exercise more, achieve their resolution. You can randomly select 65 adults in the US whose resolution was to exercise more and ask each if he or she achieved that resolution. Now it's 51%. So we can get our P, and also we have 65 adults, so we can get the N. So here N equal to 65, and P will give us 51% is 0.51. And also Q will be 1 minus 0.51, which will give us 0.49. So we find the NP, which is 65 times 0.51, that gives us 33.15. So it's greater than 5. And also NQ is 65 times 0.49. That also gives us 31.85. So this means the mean will give us 33.15 because the mean will be NP. And the standard deviation will be the square root of NPQ, which is 65 times 0.51 times 0.49. And approximately it will give us 4.03. Now, since we know that the NP and also NQ is greater than 5, then we can say we can be normally approximate. Then normal approximation is called. But again, when we look at the graph here, we can see that everything also depends on the sample size. Because as the sample size increases, then the normal approximation, we can see that histogram will be converted to a normal curve. So in this question, we can say the sample size is very big, 65 adults. So again, NP and NQ is greater than 5. And we have, so this means our mean will be 33.15 and the standard deviation will be 4.01, and we can approximate it. Now, the second question says we have 15% of adults in the US do not make New Year resolutions. Again, 15% of adults in the US do not make the New Year resolution. You randomly select 15 adults in the US and ask each if he or she made a New Year resolution. So the same thing, the sample size is 15 because we asked only 15 people. And also 15% didn't make New Year resolution, so P is 0.15. So in this case, Q will be 0.85. So NP will give us 15 times 0.15, which is 2.25, less than 5. And also NQ is 15 times 0.85, which is 12.75, greater than or equal to 5. So now, because NP is less than 5, we cannot use the normal distribution to approximate the distribution of X. So we can't get the mean, and also we cannot find the standard. So here we can see that the mean goal here because of the sample size, and also probability also the P is very low. Now let's move on to the correlations for continuity. Here we say the binomial distribution is always a discrete, and also we know the normal distribution is continuous. So a binomial distribution is discrete and can be represented by a probability histogram. So to calculate the exact binomial probabilities, the binomial formula is used for each value of X, and the results again are added together. So here geometrically, this will be corresponding to adding the areas of the bars in a probability histogram. Each bar is an area. So that's here we say when you use a continuous normal distribution to approximate binomial probability, we need to move 0.5 units to the left and also the right of the midpoint to include all possible X values in the interval. And this is the concept of a correlation for continuity. So we can see in our diagram, the exact binomial probability of give X equal to C. Now we change to the normal approximation. So now the X will be, we add 0.5 to the right, and then we subtract 0.5 from the left. So we can see X will be greater than C minus 0.5 and less than C plus 0.5. And this gives us the concept of, again, correlations for continuity. Now, using the correlation for continuity, a question is given here. They say we should use the correlation for continuity to convert the binomial intervals to normal distribution interval. So the probability of getting between 270 and 310 success inclusive. So this means that discrete midpoint values is 270, 271, all the way to 310. It's between 270 to 310. So this means the corresponding interval for the continuous normal distribution is, we subtract 0.5 from the left, so 270 minus 0.5, and then we have 310 plus 0.5. So that will be X will be greater than 269.5 and less than 310.5. Next, the probability of getting at least 158 successes. So again, this is a discrete midpoint values. It will be again 158, 159, up. We don't know because here they say at least. So the minimum we start from 158 up. So this means the corresponding interval value for the continuous normal distribution is 157.7 going. So S will be greater than 157.5. Because based on the question here, we don't know the handy. We say at least 158. So it can go 158, 159, 200. We don't know the end. But the previous example is between 270 to 310. So it will be 269.5 and 310.5. Because they say we should subtract 0.5 from the left, add 0.5 to the right. Here we say at least 158, so greater than 158. So it will start from 157.5, greater than 157.5. Next, they say the probability of getting less than 63 success. So this time we go to the left. That means it will be 60, 61, 62, or you can even start from 1, but it won't go up to 63. It should be less than 63, so we go up to 62. So since it's to the left, we are going to say that X should be less than 62.5. We can, because if we are in 62, which is the end, we had 5 to it to the right. But to the left, we don't know where we are starting. It can be from 1, it can be from 58. So it will be X less than 62.5. So using the normal distribution to approximate binomial probability, there's a steps we should follow. So first step is that we need to verify that the binomial distributions apply. We can come with our symbols. We know we need the NP and NQ. N is the sample size, P is probability of success, Q is probability of failure. So next we need to determine if we can use the normal distribution to approximate X, the binomial variable. So the condition is we check if NP is greater than or equal to 5. Also, we check if NQ is greater than or equal to 5. Then we find the mean and the standard deviation for the distribution. That's if this condition is true. If NP is greater than or equal to 5 and NQ is greater than or equal to 5, then we can find the mean will be NP and also the standard deviation will be square root of NPQ. Then next, we are going to apply the appropriate continuity corrections. We're going to shade the corresponding area under the normal curve. So this means we are going to add or subtract 0.5 from the endpoints. To the left endpoints, we subtract 0.5. To the right upper side, we add 0.5. Next, we can find the corresponding z-scores. So the z will give us x, each s value, minus the mean divided by the standard deviation. Then we can find the probability. In this case, we will go to the standard normal table. The z value, we're going to look the corresponding z value to the probability using the standard normal table to find the probability based on the z value. Based on the z value. So let's see one example here. Here they say 51% of adults in the US whose New Year's resolution was to exercise more achieve their resolution. That's 51% achieve it. So that will be our p-value. So if it's 51, then the q value will be 49.49 or 49%. Now we randomly select 65 adults in the US, so our N will be 65, whose resolution was to exercise more, and ask each if he or she achieved their resolution. What is the probability that fewer than 40 of them respond yes? Now to find the probability here means we have to follow the step until we get the z value. Here we are using the population, mean, and also the standard deviation. So first we are going to check. We find the mean to be 65 times 0.51, which is 33.15. Again, we skip that section because we did already. First, we can check the NP should be greater than or equal to 5. NQ should be greater than or equal to 5. So in this case, the sample size 65. 65 times 0.51 give us 33.15. And also 65 times 0.49 is almost around 30. So both values again are greater than NP and NQ, they are greater than 5. So if that is the case, we are going to find the mean, which will be the NP, 33.15. Then we find the standard deviation, which is the square root of NPQ, which gives us 4.03. Then after that, we know we can apply our continuity corrections. Now, fewer than 40 means we go 37, 38, 39. So this will correspond to, and we say fewer, so it will be X should be less than 39.5. Now, next we can come up with our shaded area. We know the mean, this is a normal distribution. The mean will be on the center, 33.15. And also, we know the fewer the X is 39.5. So this will be the shaded area we are looking. So next, we have to find the Z value. So the Z value will give us X minus mean over standard deviation. Again, the mean value is the condition here, 39.5 minus 33.15, which is the mean. Standard deviation is 4.03. So the Z value is 1.58. Then we have to go to our standard normal table. Then we look for the p-value corresponding to this value, Z of 1.58. So we know the shaded area. Again, anytime we look at the table, the result we get is from left to the value X section, the Z corresponding. So since we have already shaded the area, we say S is less than 39.5. So it will shade to the left. So whatever value we get from the standard normal table for the P corresponding with the Z, that will be the final. Now, if it's shaded to the right, the answer we get from the table, we subtract that answer from 1. So based on the Z value, which is 1.58, the table gave us probability of 0.9429. Again, since Z is less than 1.58, we shade to the left. And the probability value from the table is the final result. Now, let's see one more example. Here they say a survey reports that 86% of internet users use Windows Internet Explorer as their browser. You randomly select 200 internet users and ask each whether he or she uses Internet Explorer as his or her browser. What is the probability that exactly 176 will say yes? So in this case, our X value is 176. So first we need to check if we can do a normal distribution concept here. So 0.86, we select 200, so the sample size is very big. 200 times 0.86 and also 200 times 0.14 is more than 5, so we don't need to check. We go straight and find the NP for the mean, which gives us 200 times 0.86, 172 greater than 5. NQ, since P is 0.86, Q is 1 minus 0.86, that gives us 0.14. We still get 28, which is greater than or equal to 5. So this means you can find the mean. The mean will give us NP, which is the 175. Standard deviation is square root of N, 200 times P, 0.86 times Q, 0.14. And that gives us 4.91. So now we know the standard deviation. We also know the mean. We can find the continuity collections. Again, it will be, since we say the value is exactly 176, we go to the left, it will be 175.5 minus 0.5. To the right, we had 0.5. So the continuous normal distribution interval will be 175.5 to 176.5. So next we get our shaded area. So this is where our continuity will be at, collection. So now we have to find the value for z. So z will give us x minus mean over standard deviation. Now we have two z value because we have 175.5, the first x value, then 176.5. So the first z1, we use 175.6 minus 172 divided by the standard deviation. The second, which is the next endpoint, 176.5 minus 172, 4.91, which gives us 0.92. So this means our z value here will be greater than 0.71 and less than 0.92. Again, the reason why we have this because exactly 176. Now, if they said greater than 176, then we use only one, the right side, greater than 176. And if it's less than 176, it will be to the left, less than 176. So exactly 176, we saw the interval between, we had 0.5, we subtract 0.5, so this is the shaded area. Again, if it's less, we shade all the way to the left. If it's greater, we shade from the value to the right. If it's exactly, we are going to get some short interval, 0.5, add 0.5, subtract 0.5. So now we have our z value and the area we are looking for. So we are going to look for the probability value that correspond to 0.71, then the probability value that correspond to 0.92. And so that's what we get. So for 0.92, we can say it will be from the end interval to the left. Then the other one also the same thing. We have 0.7611, which will be the second z value for 0.71 goes to the from the left. So now we have to find the difference between 0.8212 and 0.7611, and that will give us the probability on the shaded area. So the result will be 0.0601. So that will be the conclusion for this lecture. So in this lectures, again, we learn how to determine when the normal distribution can approximate the binomial distribution. In this case, we use the condition if NP and NQ are greater than or equal to 5. Then also we learn how to find the correlation for continuity, and we use the normal distribution to approximate the binomial probabilities. Have to find the binomial probabilities. So again, wish everybody the best and thank you.